equations with rational numbers. This is also called clearing equations. You might hear that being referred to several times about how to get rid of um, rational numbers. And when we talk about rational numbers, we're talking about fractions and decimals. So is there an easier way to work with equations that have fractional decimals, and if so, how? We can do that, but first let's remind ourselves about what least common denominator is. When we're looking at a fraction, the denominator obviously is the number that is down below. And what we're doing is we're trying to find common denominators between fractions. So that way, no matter how big the compilation gets, you should be able to look at every single term, whether it's 2, 4, 12, putting it all together, knowing that the least common denominator for this particular one would be 12. Now remember, another word to think about is the least common denominator. We might want to say least common multiple. That sometimes helps people out realize what we're talking about when we're looking for that least common denominator. Because if we take multiples of 2, 2, 4, 6, 8, 10, and 12, the multiples of 4, 4, 8, and 12, we can see that they're all going to hit 12, and that's the lowest number that they all have in common. So we're kind of looking for the lowest number that they all have in common when we're talking about their multiples. Okay, so let's talk about fractions first. In order to do this, to make the equation easier to deal with and to get rid of the fraction, is we need to find the least common denominator and then multiply all the terms by that number, and every term, regardless if it has a fraction or it doesn't. If you do this, this will get rid of all the fractions and have an easier equation to work with. So here we have 1/3 p plus 1/6 equals 3 over 2. So what we want to do is take a look at this and notice that the least common denominator happens to be 6. Knowing that it's 6, we want to multiply everything by 6. So we're going to multiply this one by 6, this one here by 6, and also this one by 6. What that does for us is it's going to help us to make these equations smaller. So 3 goes into 6 2 times. 2 times 1 times p is 2p. 6 goes into 6 1 time. 1 times 1 is 1. And 2 goes into 6 3 times, and 3 times 3 is 9. You can see by looking at the equations, let me move this out here, the blue one is a lot easier to work with than this one here that's a fraction. Put it back. That way, we can kind of keep an eye on what's going on by drawing a line here and finishing solving it. And now it's a normal two-step equation. So if we subtract 1 from both sides, we'll get 2p equals 9 minus 1, which is 8. I'll draw a line in here to kind of keep it straight for you guys. And then divide both sides by 2. So we can concentrate on each step. 2 divided by 2 is 1. 1 times p is p. And 8 divided by 2 is 4. So we're going to check and see if this answer p equals 4 is going to work out. So we have to plug in the original equation, this 4. So 1/3 times 4 plus 1/6 equals 3 over 2. We're going to multiply this out. We get 4/3 plus 1/6 equals 3 over 2. We must follow the rules of fractions. So we're going to multiply this 4/3 by 2 over 2, which is 1. So it doesn't really harm it, but it makes it a little bit bigger. Becomes 8/6 plus 1/6. We know 8/6 plus 1/6 is 9/6. And we can reduce 9 divided by 6 if we divide both top and bottom by 3, and again by a fraction of 1, so it doesn't harm it. And we see that both sides are exactly the same. So that means that our answer is p equals 4. Let's go again here. We have 3/4 n minus 18 equals 1/4 n minus 4. We want to find that least common denominator. When we look at it, the only denominator we have is 4. So 4 is it's going to be. We're going to multiply every term times 4. So times 4. Multiply this one times 4 and this times 4. So 4 will go into 4 one time. 1 times 3 times n is 3n. 18 times 4 is 72. And the 4's here will cancel, giving us 1 times n, which is n, minus 4 times 4, which is 16. Split the sides here. See what's going on. Now what we want to do is work on getting the variables to the same side. So let's subtract an n from both sides. That'll give us 3n minus n, which is 2n, minus 72. equals n minus n goes to 0, so that crosses out, leaving us with negative 16. We then want to do is add 72 to both sides so that we can isolate the variable. The 72s will go away, just leaving us with 2n. Negative 16 and positive 72, they are opposite signs, so we're going to take the difference, and so that's going to work out to be 56. Then we're going to divide both sides by 2, and we find out that n equals 28. So what we're going to do is check our solution to make sure that it's right. So 3/4 times 28 minus 18 equals 1/4 times 28 minus 4. We're going to do 1/2 at a time, so let's do the left side first. 4 goes into 28 7 times. 3 times 7 is 21. 21 take away 18 is 3. Over here on the right, 4 goes into 28 7 times. 1 times 7 is 7. And 7 take away 4 is 3. So since both sides work out, n equals 28 is the answer we are seeking. Now let's talk about decimals. We want to find the least power of 10 that is common in all the terms and multiply by the terms by that power. So what do I mean by that? If we notice that something is at the 10th place, that means we're going to multiply everything by 10. If it ends up going to the 100th place, that means we would multiply everything by 100. So whichever decimal places we have the most, that's what we're going to multiply by. So let's take a look at this problem here. We have 0.5r plus 1.5 equals 3. If we multiply everything by 10 because of this decimal, so 10, 10, and 10, remember everything is going to get it regardless if it has a decimal or not, just like we did with the fractions. Then we simplify. What that does is it moves the decimal over, so we get 5r. Plus, instead of 1.5, we now have 15. And 3 times 10 is 30. So it makes things a little bit simpler. So we're going to subtract 15 from both sides. That way this goes away. We're going to get left with 5r equals 15. Then we're going to divide both sides by 5. And we get r equals 3. We're going to check our solution. Plugging it in. 5 times 3 is 15, and with that decimal, that gives us 1.5, or 1 5/10. 1 5/10 and 1 5/10 is indeed 3. So our answer did work out to be 3. We're going to try one more problem. Here we have 3.6w equals 1.6w plus 24. What we want to do, since everything's to the 10th place that we see, we're going to multiply everything by 10. Even this 24 is going to get a 10. And we're going to rewrite. So we get 36w equals 16w plus 240. So what we want to do then is to combine terms. We're going to keep 36w and get rid of the 16w from both sides. That's going to give us 20w on the left. 16w's go away. We have 240 on the right. Divide both sides by 20. And we get an answer of 12. We're going to check and see if our solution is good. 3.6 times 12 equals 1.6 times 12 plus 24. Okay, so we're going to start to work it out. We know that 3.6 times 12, when we multiply it together, is going to be 43.2. And 1.6 times 12 is equal to 19.2. And when we add 19.2 and 24, we do get 43.2, so it does work out. So our answer is W equals 12. So that does work out. So hopefully this explains a little bit about how to work with rational numbers, an easier way to get rid of them so that you can continue working the problem.